Hello again. We are just going to go ahead and jump right into our next problem. So we are told that a cafe has a 12-yard by 15-yard patio with a surrounding walkway that is X yards wide, and that the perimeter around the outside of the walkway is 64 yards. And then they want us to determine the width of the surrounding walkway. All right, so this is a geometry problem, and let's draw a picture of what we have. So we have this patio. And we know that it's one side is 12 yards and that the other side is 15 yards. And then we also know, and I'm actually going to put this inside the box, that there is a walkway around it. So we have this big walkway around it. And the walkway is, we're assuming that it's symmetric all the way around. Just kind of hard to do with drawing, but just assume that it's symmetric. And we know that they are representing the width of this walkway with X. Okay, what else do we know? We know that the perimeter is 64 yards, which means if I add up 2 times one of the sides plus 2 times the other, we'll get 64 yards. Well, how could I represent this length? Because we don't know anything about it, right? We do know that this right here is 12 yards. And we also know that the width from here to here is X yards. And the width from here to here is X yards. So how could I represent this length right here using only what we're trying to find / what we know? Well, it's 12 plus 2 times our X. So the way we represent, let's call the length, call this the length and this the width. We represent the length with 12 plus 2 times X. Similarly, we can represent the width as 15 plus, again, the length from here to here is X, and the length from here to here is X. I know that doesn't add up the way it's drawn, but it is the case. And so we can represent the width with 15 plus 2X. All right, well, how does that help us find X? Well, what do we know this length and width make up? It makes up the perimeter. We know that 64 yards is composed of 2 times the length plus 2 times the width. Now, let's just plug in our problems, or our expressions. So we know that the length is 12 plus 2x, so we have 64 equals 2 times 12 plus 2x plus 2 times 15 plus 2x. And now look at this. This just looks like our typical linear equations that we were solving in our linear equations video. And we can solve it the exact same way. So we start, we go through PEMDAS. We say, okay, parentheses can't be simplified because we can't combine 12 and 2x or 15 and 2x. There are no exponents we have to deal with. So the next thing we go to is multiplication, and that's going to be distributing these 2's into those parentheses. So right now, we're going to start by distributing the 2 into the parentheses. That gives us that 64 equals 2 times 12 is 24, plus 2 times 2x is 4x, plus 2 times 15 is 30, plus 2 times 2x is 4x. I will try to get better at using my pointer. I tend to point things with my pencil without actually turning on my pointer so that y'all can see what I'm pointing at. But hopefully you've been able to follow along so far. Now, just like before, we're going to combine like terms. So we're going to combine this 24 and the 30, and then also the 4x and the 4x. And that gives us that 64 equals 24 plus 30 is 54. And then 4x plus 4x is 8x. Then we just need to solve for x to find the width. How do we do that? Well, we start by, we want to get x by itself. That's the goal. And the furthest thing away from x on this side right now is the 54. So that's the first thing we're going to be moving over. It's positive. So to move it to the other side, we're going to subtract it. 54 minus 54 is 0. 64 minus 54 is 4 minus 4 is 0. 6 minus 5 is 1, so it's 10. So we have that 10 equals 8x. Now we're still multiplying by 8 to that x. So to get x by itself, we divide by 8. 8 divided by 8 is 1, and we get that x equals 10 over 8. But wait, we're not done. You always have to make sure a fraction's as simplified as possible. 8 and 10 both have 2 in common, so we're going to divide both the top and the bottom by 2. Excuse me, I want to use my green color like we do when we're dividing. And that's going to give me 5 over 4. So we get that x equals 5 over 4 yards long. Does 5 over 4 really help us, though? I mean, think about the situation we're looking at. We want length. If I tell you something's 5/4 of a yard, does that help you? Not really. So what we really want to do here, and you can always base this off the situation you're looking at, is convert that yards to, or that fraction to a decimal. The way we do that is long division. So Norma goes inside the house. If you haven't heard this before, there's a saying that says Norma on the donkey. So Norma rides a donkey, right? The human rides the donkey. And when the human gets home, it goes inside the house. So Norma's inside the house. And where does the donkey stay? It stays outside the house. We will use this again when we review complex numbers and rationalizing the denominator. But anyways, so then we ask ourselves, how many times does 4 go into 5? It goes in once. 1 times 4 is 4, and then we subtract them, and we get a remainder of 1. So 5/4 is 1 1/4, and 1/4 is equivalent to a decimal of 0.25. So x is 1.25 yards long. And so what is the answer to our question? The width of the surrounding walkway is 1.25 yards. And that is all we needed. All right, go ahead and move on to the next video for the next problem. And if you're curious as to why there's different videos for each problem, YouTube takes a while to upload something that's too big. And so I'm trying to kind of break down the videos. That way it doesn't take as long to upload, so y'all can get them as soon as I'm able to make them.